What's going on, everybody? Good morning. Good morning. Good morning. All right, so let's give everyone a moment to check in and say hi and see what's going on. In the meantime, we need to talk about the schedule. So I'm going to go to the whiteboard just so I can write this down and we can kind of literally put this in black and white. All right, so what's going on, Connor and Kaylin, my two regulars? Like I mentioned, we're going to figure out the schedule for the next few days and get this nailed down so we're all on the same page. So let's go right to the whiteboard. All right, so we got, let's say, Monday, Tuesday, Wednesday, Thursday, and Friday. All right, so here's what we're going to do. We're going to just take Wednesday and we're going to cross it off the list right away. No video on Wednesday. All right, it's a breather day. Let's just keep it at that for this week. All right, so today is going to be a Q&A day. All right, because you got that assignment that's due today. All right, and let's see. Let's do it noon. And there are 10 people who have turned it in. Both you guys have turned it in, so you guys are okay. So as far as the Q&A, I don't expect much. The last real assignment has been turned in by you guys, and that's that. We will also begin talking about organic chemistry. All right? So that'll be explained. There's going to be no test or quiz or any real thing with this. This is just going to be me talking about some stuff that I think is interesting. Tomorrow will be the same thing. We're going to shorthand that to Orgo. No video on Wednesday. We'll do a discussion on Orgo the rest of the week. Okay? I hope that makes sense. And again, this Orgo or organic stuff is nothing like, no real assignment for that, to be honest with you. Just to keep things a little interesting. I find that aspect of chemistry the most entertaining aspect. So we'll be talking about that. So I'm assuming you guys don't have much of a Q&A type of thing today because, you know, you already did the assignment and it's due today. So it's not like you can all of a sudden have questions about an assignment you already turned in and you know, that's that. But that's the schedule for this coming week. Not much. School's just about over. It would be at this point in the classroom where we would be reviewing for the final exam and what have you. So, and since that isn't going to happen the way it's traditionally been done, you're stuck with this. Now, to be honest with you, back when I taught AP chemistry, and I even do this occasionally with honors, towards the end, if we have a week or two like we do now, we would be going over this Orgo stuff anyway. And it's just to give you a glimpse of what would happen in college chemistry. So there's no, like, weight to this. There's no, whatever. It's not going to change your grade. Everybody cool with that? Are we on the same page in terms of the expectations? We're just going to be talking about some interesting things. This kind of keeps me fresh with this as well, and it is what it is. So let's go back to the whiteboard. I don't see any questions popping up. So here's the deal. Now, keep in mind that this discussion is going to be incredibly, like super incredibly simplified because of our lack of prep for organic. Normally in college, you would have Orgo 1 you would have your first year taking regular chemistry. Kind of like what we did here, you would cover a lot of the same stuff, but in way more detail over a longer period of time. So like September to May, you would be talking about stuff that we just scratched the surface of together. And then your second year, your sophomore year, you would be taking organic chemistry, and that's what starts you on the path of becoming like a doctor or a biochemist or a pharmaceutical engineer or a biologist or anything involved in the life science or the physical science of chemistry. Does that make sense? Not physics. Physics will not be taking organic chemistry. When I was in college, I was a biochemistry major. So I had classes with biologists, or let's say biology students, chemistry students, biochemistry students, and my first year chemistry was with physics as well. So there was a lot of like overlap with all these different majors. Now, having said that, after your second year or so, a lot of majors start to separate and specialize. So the biology students, they took Orgo 1. They may have taken Orgo 2. I don't recall. Let's say they took Orgo 2. All right. So it's 4 semesters that I had with them. After that, they went off and they stopped with chemistry. They may have taken a biochemistry class in their senior year, but they were done with chemistry. Chemistry students, they took those first 4 classes, semesters 1 and 2, your first and second year, all the way up to Orgo 2. But then they took like Orgo 3, Orgo 4, and all kinds of other stuff, and they kept going with the chemistry stuff. But they stopped with the bio. So it was after your second year into your junior year where the biology majors and the chemistry majors began to separate, and they kind of lost touch with each other, and they actually started to lose the ability to communicate about their classes. Well, that's where I came in. I had to take it all. As a biochemistry major, I had to take it, not all the bio classes, but I took way more than any chemistry major did. And I also took all the chemistry, maybe not all the chemistry, but I took way more chemistry than a biology major did. So I had friends that were in both majors, and I was kind of like the overlap whenever we it's not going to sound like I had a good time in college, but whenever a group of people got together for any sort of reason, and they were of different majors, and the biology majors wanted to ask what the chemistry majors were studying, and they had no idea what these guys were saying, I would translate. I had not the highest level of knowledge, but I had a reasonably high level of knowledge of both, where I could then help either. And I was actually tutoring both bio and chemistry majors in college. And it turns out with my degree, I have enough college credits where I could teach any science class except for physics. I would have to take some more physics classes to get certified in physics. But I could teach any of the bio classes that this school runs. I could teach any of the chemistry majors that this school runs. Any chemistry and biology classes I'm capable of teaching, and I have the New Jersey certificate to do so. It is what it is. So that's that. Okay, so organic chemistry, all right? Organic chemistry is the study of carbon and how it interacts with other elements and the compounds that can be used or made from carbon. So we're going to be talking specifically, at least for a little while, carbon and hydrogen. Remember that term, hydrocarbon? When we did, unit 7, when we did reaction types, and we talked about hydrocarbons and the combustion. Well, this is going to kind of go a little deeper into that, at least for a little while. I won't take up too much of your time today, okay? You guys were gracious enough to join me as much as you did, and, whatever. So, not all compounds involving carbon are considered organic. Like, to be honest with you, one example would be diamond. A diamond is just pure carbon, okay? But that's not considered organic. CO2, I don't remember. Whatever. So there are exceptions to this rule, but for the most part, we're going to consider just about every compound with carbon as organic. And then you could throw other stuff on there. You could throw hydrogens, oxygens, chlorines. You could throw nitrogens. You can throw all kinds of stuff. But as long as it's got a base of having a bunch of carbons, you now have an organic compound. The simplest organic compound is CH4. That's the simplest one. It's the most basic one. It is basically going to be used to build other organic compounds. Now, do you remember all those prefixes when we did the, what do you call it? Molecular compounds, right? There was mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Remember those guys? All right. Well, I'm going to give you a list of another 10. So you got meth. It's not what you think it is. Meth, eth, prop. Okay. Metheth, prop, bute. It's been a while. All right. Bute, pent, hex, hept, octa, or oct. Yeah, oct. Oct is what we want to say. I'm getting ahead of myself. And then there's nana or non, and then dec. All right, so here's the deal. We're going to start by assuming that carbon, well, this is true. Carbon needs 4 bonds total to make it happen. Okay? Now, it can make those 4 bonds in a number of ways. All right? It can have a single bond to another element, or it can have a double bond to another element, or it can have a triple. So single, double, and triple bonds, as long as it all adds up to 4. So I'll come back to these prefixes in a moment. So if I had CH4, that means it has 4 hydrogens. Remember, that's the simplest compound that's organic, right? So CH4 would look something like this. Let's get my smudges out of the way so it's clear. You got a carbon with 4 hydrogens. They're spread out evenly, okay? This is going to be called methane because it's only got 1 carbon. So this goes in order. 2 carbons would have a name of ethane. 3 would be propane. They're all going to end in ane, okay? Butane. Pentane is 5. Hexane is 6. Heptane is 7. Octane is 8. That's what your fuel is based on for your cars. Nonane is 9. And 10 is decane. All right. So the fact that they all end in ane mean that everything is made up of single bonds. If I had double or triple bonds, they would have a different ending, but they would still have the same prefix. So now that you know what they are, let's take a look at this thing here. Let's say I had, let's just do an easy one, butane. Okay? Butane is 4. So you got 4 carbons in a string together. Now, each carbon needs 4 bonds. But it looks like this carbon has only 1 bond so far. So it's understood that the rest, or the other 3 bonds, are going to be hydrogen. Okay? This carbon already has 2 bonds. It's bonded to these other 2. That means it needs 2 more. Okay? Same thing here. This carbon on the end is just like this guy. It's already got 1, but it needs 3 more. So it has 3 hydrogens. So that would be the name of, or that would be the structure of butane. And you could do this for any of them. So methane, as we said, is 1 carbon. So it would be carbon with 4 hydrogens. Cool. Ethane would be 2 carbons, right? And then it's going to have your hydrogens to make up those missing bonds to get each carbon to 4. So the formula for this would be C2H6. Okay? C2, you know it's ethane right there because it's got 2 carbons. Now, I could do a crazy one like octane, okay? Octane is going to have C8 or 8 carbons. So you just do 1, 2, 3, 4, 5, 6. Yeah, it's 6, 7, 8. And then you fill in the hydrogens from there. There would be 3 over here. I'm condensing it to make it look a little easier. Okay? There would be hydrogens, only 2 of them, on each of these interior carbons. And then these carbons on the end, we're going to call them terminal carbons because they are terminating the compound. They're at the end of the line. It's the last stop. It's terminated. So it's the terminating carbon. That's why you call train stations terminals, because it's where people get off. They're stopping their ride. It terminates their trip. So you can do that, H3 on a carbon. Now, here's where things get weird. You ready? we're going to do what we would call a line structure. We could do octane again. There's a way to make this even shorter of a drawing, okay, to make this a bit more interesting. Now, you're going to do what looks like a zigzag line, okay, and each intersection or the end of a line represents a carbon. So say I want to do 8 carbons. When you put your pencil down, that represents the first one. You go up here, that's the second, that's the third, fourth, fifth, sixth, and seventh. And we need one more, 8. All right? Now, when you draw this, each, like I said, the end of each line represents a carbon, as well as any intersections. Then you don't even have to draw the hydrogens because you know each carbon needs 4 bonds total. So this would be a CH2. This would be a CH3. CH2, 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 and CH3 or H3C, whatever. So this represents octane in a different way. But a true line structure doesn't have those letters written in there. Okay? So let's do one like pentane. Pentane has 5, like a pentagram, right? Or the prefix pent that we learned for the moleculars. So I got 1, 2, 3, 4, 5. There you go. You just drew pentane. That's an organic compound. At least that's how we represent it. Okay? Now things get weird, okay? There is a pattern for these formulas. So let's start with CH4, methane, C2H, we'll figure that out. C3H, how many? We'll get there. C4H, we'll figure out how many H's. So your methane, we know you really can't draw a line structure because you're not drawing a line, but if you were to, it would look like that. It's 1 carbon. In reality, this is how you would just represent methane, and that's another name for natural gas, to be honest with you. That's the gas that you use to run your stove, your hot water heater, and stuff like that. So if you ever smell gas, this would be the gas that is leaking. Technically, this gas is odorless, and they put in a smelly compound in there. So since this is odorless and it's explosive and dangerous if it's leaking into your home, they inject another chemical that's smelly. So you smell that representing a leak. I hope that makes sense. So anyway, methane or natural gas. This is ethane. It's going to be written out like that. 1 carbon, 2nd carbon. You know that each of these carbons have what do you call it? 3 more bonds. So there's going to be a total of 6 hydrogens. 3 here, 3 there. So C2H6, right? This is going to have 3. So 1, 2, 3. Each end is going to have 3, so you're up to 6 carbons, another 2 in the middle, so now you got 8. Okay? This is going to have 4, so 1, 2, 3, 4. That's butane. I got 3. 2 is 5. 2 more is 7, plus another 3. That's 10. All right, so now there's a pattern here. This is what I was trying to get you at. All right, so anything that ends in an ane is what I'm trying to think of, okay? Methane, propane, so on. It's what you would call just a straight chain, right? It's just carbons and hydrogens hooked up in a long straight line. We draw it zigzag to represent them, though. They all end in ane, okay? They're all single bonds, so anything with only single bonds ends in an ane. We're going to call them alkanes, okay? All right? Single bonds only, okay? Carbons and hydrogens. Okay? So you can have as many as you want. And to be honest with you, those prefixes I gave you are just the beginning. They go up to into the hundreds and thousands, and it gets really like crazy. So anyway, there's a pattern. It's always C, N. I'm trying to remember this. H, 2N plus 2. Did I do that right? N is 4 times 2 is 8 plus 2. Yeah. So here is the formula. So having said that, if I have a straight chain alkane of, let's say, C7, right, which would be heptane, I want to know how many hydrogens. Well, 7 is going to be represented by this number, or this variable n. So I do 2 times n plus 2 would be 16. All right, so that's how you figure out the formulas for these things. We could double check. Let's do heptane. So 1, 2, 3, 4, 5, 6, 7. Okay, that would be the line structure for your heptane. Let's double check how many hydrogens. Hopefully I got the formula right because it's been a while. I got 3 here and 3 there. The ends always have 3. There'll be 2 at each of these. All right, so I got 3 plus 3 is 6. This is 6, so 12, plus another 4, it's 16. I could do it again. 3 plus 2 is 5, 7, 9, 11, 13, 16. So that CnH2n plus 2 represents all alkanes, all straight chain alkanes. Now, I keep saying alkanes. I also keep saying straight chain. Sometimes these things branch. And one type of branch is what we would call cyclo, or like a circle. A real common one is cyclohexane. And what is going on there? It's a hexane, so it's going to have 6 carbons, right? Well, cyclos don't follow that 2n plus 2. Now there's something different. So what you got here is 6 carbons arranged in a circle, or a ring would be the proper term in this. And you just got to draw a hexagon. Each intersection indicates a carbon. So I got 1, 2, 3, 4, 5, 6. Each needs 2 hydrogens because it's already got 2 bonds. So 2, 4, 6, 8, 10, 12. Well, cyclos follow the pattern of CnH2n. Since there's no terminating, everything's just in a ring, and you just keep adding 2 carbons or 2 hydrogens to each carbon. This gets crazy, okay, that we're just beginning, because I spent, I would say, several weeks of one semester on just cycloalkanes, and it just gets nuts, okay? It goes crazy and crazy. Now, what we're going to do, since you basically got a crash course in straight chain alkanes of organic compounds. Look at the words that you guys are using. All right, we're going to start naming them, okay? Not all of them are straight chains, though. So let's say I got 1, 2, 3, 4, 5, 6, 7, all right? But then I'm going to put another one up there. All right, now what do you do? Okay, you can't call this a heptane because it's got this little thing hanging off there, all right? That changes the entire compound. Okay, so here's what you do. You first find the longest chain. And we'll stop after this one. All right, so that's going to be the basis of the name. Okay, so this is going to be heptane. Then you count from the end until you get to the carbon that's got the junk hanging off of it. All right, now in this case, if I go 1, 2, 3, 4, that's the 4th carbon. But if I go from this end, 1, 2, 3, 4, it's still number 4. If I were to put this over here, you got to go with the smallest number. So 1 and 2 versus 1, 2, 3, 4, 5, 6. So I would say 2, not 6. You always go with the lower number. So this is going to be 2. You ready? Basically, we're saying we got a heptane, but on the 2nd carbon, I got something here. Then you just say what it is. Well, it's not a methane, because methane is CH4. This is a methyl, because it's kind of like a methane, but it's only a CH3. The 4th bond is to that carbon. So we're going to say 2-methyl hyphen heptane. Wow. Okay. One more, and we'll see what we can do tomorrow. Okay? Are you guys still with me? Anyone out there still watching this nonsense? What is going on there? All right? Let me know if you guys are still alive. I got Connor. He says it makes sense. You're the man, Connor. All right, here's the deal. Step 1, find longest chain. Okay? Now, there might be some trickery going on here. I got 1 carbon, 2, 3, 4, 5, 6 in that direction. I got 1, 2, 3, 4, 5, 6, 7 in that direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So this is going to be heptane again. Right? 1, 2, 3, 4 versus 1, 2, 3, 4. So I'm going to have 4 something heptane. Right? Both you guys are there. Cool. Now, on the 4th carbon, I have a 1-2 carbon combo. So it's going to be an ethyl, 4 ethyl heptane. This is the beginning of learning like pharmaceuticals and stuff like that, since all pharmaceuticals, let's call them organic, okay? Without organic chemistry, there would be no medicine. There would be no creating new drugs. There would be none of that. Did you know that aspirin was originally synthesized from the bark of a birch tree? And it was found out that the bark of the birch tree has salicylic acid, which is the precursor from the chemical known as aspirin. So a lot of this stuff comes from nature, and nature makes organic chemicals. Right? It's just the way it is. There's, I forget what plant it is. I want to say it's the dogwood. Let's look up this thing real quick, and I'll leave you with this story. Let's see. I'm looking up this thing here. Where'd it come from? There's a compound or a brand called digoxin. It treats heart failure and arrhythmia problems. So if you have an irregular heartbeat or anything like that, you're going to potentially be thinking about taking digoxin or digoxin. It's a treatment for such. Now, where it came from is, I want to say the dogwood. I'm on the Wikipedia page, and that's, not helping me. So I'm going to go digoxin. I'll write that down for you in a second. Dogwood. I have a story about this. Let's see. Interesting. All right. So anyway, the dogwood berry. Prettiest plant of fox like a digestion. Anyway, there's this chemical called digoxin, and it's found in a variety of plants. One such plant, I believe, is the dogwood. I could be wrong about that, but let's say, just for argument's sake, for the discussion, it is in the dogwood. Now, digoxin is spelled like this. Okay, for a while, and this is kind of what got me into chemistry. When I was 16, I got a job working in a pharmacy, and I was in charge, for lack of a better term, of dispensing medications to people based on their doctor's orders. And I learned a lot. I learned a lot about customer service. I learned a lot about science. It was a critical time for me of how to learn how to interact with people. And it was a very interesting time for a young person like myself to deal with mostly sick people who were impatient and wanted their medications right then and there because they're sick. I get it. It was an interesting learning experience. So anyway, one such medication that we dispensed was called digoxin, and it's an older drug. It's been around for years and years. I was 16 in 1997, so this was we're going back almost 25 years when I first started learning about this stuff. So anyway, digoxin is used for heart arrhythmias and heart medications and stuff like that. And if you have an irregular heartbeat, it stabilizes your heartbeat. But if you're healthy, this could potentially cause issues because it's manipulating your already healthy heartbeat. And it's not exactly a good idea to take a healthy heartbeat or heart rate and throw chemicals at it and then change it. See where I'm going with this? Anyway, I had a old boss who will remain nameless, and he told me a story that when he was in high school and college, he was thinking about becoming a pharmacist. Well, eventually he got to the point where he's going to pharmacy school. And pharmacists make a decent amount of money. So if you're looking for a reasonable job where it's not that physically taxing, you're kept in a air-conditioned building during the summer and heated in the wintertime, you're not working outside. The most dangerous thing that could happen is maybe a paper cut. Just saying. And you're making probably $100,000 or so a year. It's a reasonable job. Takes a lot to get the education, and you're also considered a doctor. So you're a doctor of pharmacology. Anyway, this old boss of mine, he will remain nameless, like I said, told me a story that when he was in college, he had a couple of roommates. One was a pre-med or medical student. I'm not sure. So I'm pretty sure he was a med student. So he was in actual medical school. And he had a veterinarian student. These three guys, he had a pharmacist, a veterinarian, and a doctor all living in the same building, in the same apartment. It sounds like the beginning of a bad joke. With that in mind, they actually neutered their dog on their kitchen table, he told me. The three of them used their skills together to come up with a safe anesthesia amount. They did all the math based on the dog's weight. The doctor and the veterinarian neutered their dog on their kitchen table using skills that they had learned in class. So it can be done, okay? I don't advise it, but it can be done. Next, this is the real story. To make money, because you're in college, you're broke, you got to eat, he would do odd jobs. Well, one of his friends, his father or uncle or somebody in their family owned a business where he would flip houses. He would buy houses, fix them up, clean them out, paint them, sell them for a profit. Okay? People do that today. So anyway, as a side job, he would get hired by this friend's uncle, whoever it was, to help clean out these old houses and paint and stuff like that, kind of fix them up. You get paid a couple bucks an hour, you get pizza money, okay? That's what life of a college student is. So, moving on. This guy bought a house and it needed to be cleaned out. Or apparently there was a feral cat living in the house. It must have been like an open window or a way out somehow because the cat was coming and going. But they had trapped the cat, and this cat was vicious, apparently, trying to kill them. I mean, you're in the cat's house, right? He's trying to keep out marauding invaders. So they trapped that cat in a bedroom, him and his friends, and they couldn't get the cat out. Every time they went in there, the cat would attack them, and they'd get all scratched up. So my former boss had access to medication at the pharmacy he was working at and got some digoxin. Now, these pills are super tiny, okay? But it's a very potent medication. You do not need a strong dose to get an effect. Well, he got some pills. They put it in like tuna fish or peanut butter or something, and they fed it to the cat. They threw it through the door, shut the door. Next thing you know, the cat literally, and I wasn't there, I don't know anything about this. Again, I'm not implicating any friends, but the cat had a heart attack. It's sad. It's sad, really. But this feral cat went into cardiac arrest based on the chemical that was put into its body. And they were able to take the cat out. And the cat survived. The friend was a vet, kept it okay. And they got to rehome it. They rehomed the cat, and everything turned out okay. But they had to get the cat out of there. I don't know why they just didn't call, animal control or what have you. That's what I would have done. Anyway, so that's that. That was the beginning of your organic lesson. We talked about the prefixes, straight chain, alkanes, single bonds, carbons need 4 bonds, and we started naming them. Longest chain first. Okay. Then we got into pharmaceuticals. Who would have thought? So I'm going to leave you alone now. You guys have been very gracious sitting here watching me in my green shirt, 2 of me, and, listening to this rambling, crazy person on the other end of your screen. In the meantime, tomorrow we will do a little bit more. This is just interesting to me. Cool, whatever. Wednesday, no video. Okay? Take a break. It's the end of the school year. Thursday, we'll be back, and we'll start getting into more advanced stuff where we just kind of talk about this. Okay? Cool. I will see you guys tomorrow, and I got to get ready for my honors. They have an assignment that's due later this week, so I'm going to be available for Q&A for them. All right? Cool. I will talk to you guys tomorrow. In the meantime, stay out of trouble, stay safe, and stay healthy. See ya.
What's going on, everybody? Looks like we are live, and I got a couple people here already. So, if you're there, please say hi, and so I can see what's going on. Apparently, there was a brief delay when I switched cameras. I'm not sure what's going on there. Anyway, I think we're good. So, what's up, Matt? What's going on? Anybody else around? Okay, so here's the deal. We're going to come up with a schedule. And we're just going to start talking about that. Cynthia, how are you? And then we'll move on with the Q&A, and we'll go from there. So let's do this thing. So we got the whiteboard, all right? The day of the week is Monday. Then you got Tuesday, Wednesday, Thursday, and Friday. So right off the bat, what we're going to do is we're just going to put a big old X through Wednesday. We're not going to have, hey, Zach, what's happening? We're not going to do a video or a Q&A on that day. It's a breather day. I'm going to take a step back. It's the end of the school year, so that's that. Now, with that in mind, we're going to have a Q&A day pretty much until the end of the week. All right? Now, hi, sweetheart. My wife is checking in as well. Again, I swear she's just making sure I'm working. Now, Friday is going to kind of be up in the air. We're not totally sure what's happening that Friday. What I may do, you know what? Let's just do it. I'm going to change the due date from Thursday to Friday. Actually, I already did that. Okay. So, yeah, let's make it due Friday. So that means we're going to have a Q&A day all this week. Each session that we're going to have is just going to be trying to figure stuff out. So if you have any questions, any things you need to talk about, we can use these times all at 9 a.m. to figure that out. All right? So no video Wednesday, but every other day is going to be 9 a.m. Q&A. All right? That thing is due Friday. I would suggest get on it and get it done, but that's that. At the moment, there is no one who's turned it in. But you also have another assignment that's due today anyway. That should have been due last Monday, but I put in the wrong date. So whatever. So do that one if you haven't. Then get started on this one that's due this Friday. You have 5 days. It's almost a week. All right? So get that done and ask some questions. If you haven't looked at it yet, I get it because of the due date that we put in. And
It seems like the video is buffering a little bit from time to time. I'm not sure why. I'm going to blame Comcast. So, are there any questions about this assignment? If not, I'm going to back away and take care of some other stuff that I need to do. I got some grading and online training for school and stuff like that I got to do. So, you guys got to ask some questions, or just say you don't have any questions. So those are your options. I got Matt, Cynthia, and Zach. If you guys are good, you got to give me a thumbs up or what have you. Got to let me know that you're okay. And okay, Cynthia, no questions. That leaves Matt and Zach. If you don't have any questions, I will let you just go do your homework. I'm not gonna, hold you up. Please let me know sometime soon so I can stop stalling and looking like a creep in my green shirt, sitting here talking to nobody. All right, pal. Good morning. I didn't see you here earlier, but thank you for showing up. And I got a thumbs up from you. Anybody else? Matt and Zach, we're waiting on you guys. That's if you're still here. Now, I'm looking at the people, the number of people. I can't see who's watching, but I can see how many. And this is probably the highest day so far at 6. Okay, so Matt says no questions. Already did half. The rest seem doable. Might need to review some of the older sessions. That's well said, Matt. That's exactly what I need you to worry about. You're handling this in the perfect way. And Zach, none but the assignment. However, what's your favorite football team? Well, I grew up in a household that if you're not an Eagles fan, you should be removed from the family tree immediately. So I'm going to say by default, I'm an Eagles fan. But it's not like my life revolves around sports. I'm a very casual fan. I'm more of a fan of the sports than anything else. I'll listen to some sports radio here and there, and I'll get my headlines and all that. So I listen to Zach as an Eagles fan. You saying that you're a Giants fan. You lost a couple of points as well as some respect from me, but there's not much I could do about that. So anyway, your parents did not raise you properly. So, yeah, I would say the Eagles. If I had to pick a team, I would definitely go with the Eagles. My wife, Tina, is a diehard Eagles fan, and it is what it is. So I think she'd kill me if I was not an Eagles fan, too. It is what I got to do. But I do I casually pay attention to the other sports. Not so much baseball. I just find that incredibly slow and boring. I've been dipping my toes into the idea of basketball. Not so much the sport, but more about the personalities involved. All the, the drama that comes with it and everything. That's fairly entertaining. And I've been listening to the Pat McAfee show. He's got a YouTube show that he does. And that guy is just very entertaining. He was a former punter for the Colts during the Peyton Manning era. And he's got his own sports show. And he talks about all sports. And he's very funny, very entertaining. So if you're into sports at all, Pat McAfee is the guy to watch. So seems like Zach already knows about him. And he's very, like I said, entertaining. So I've been listening to that, and that's how I get a lot of my sports. On YouTube, I'm subscribed to ESPN. So I get these like little video clips that pop up, and I'll watch one every once in a while. And that's kind of how I stay on top of things. But it's not like I'm out, I don't play fantasy football. I don't bet. I don't do any of that nonsense. That's just not for me. I don't fill in brackets during March Madness. Everyone's got to fill in a bracket. Here's your bracket. You do your bracket. Where's your bracket? What's your bracket look like? I don't care. Leave me alone with your brackets. I have life to live. Anyway, with that, it doesn't seem like there's any real questions. Everybody seems to pop in with a thumbs up or what have you, and we'll go from there. I dropped a Luke because you like Pat. You dropped a like because you like Pat, but I'm still disappointed about the Eagles. Oh, you gave me a like because I like Pat, but you're disappointed about the Eagles aspect of all this. I get it, Zach. That's all right. Not everybody's perfect. It's when you choose a team to be a fan of, it's you're going to upset some people. So I can't hold it against you for being imperfect. It is what it is. So I'm going to go away because now we're just talking crap and we're not really getting anything done. I'm going to give you guys time to go away and you can go work on those assignments that you have. And with that, I will see you guys tomorrow. So we'll do 8 and 9. My 8 a.m. is for my non-honors, 9 for you guys. The non-honors at 8 a.m., we're actually doing some organic chemistry stuff that we just didn't really, me and you, get a time to do. So there's no test or anything. It's just something we're talking about. So with that, I'm going to see you guys tomorrow at either 8 or 9 is the plan, okay? 8 for honors, 8 for non-honors, 9 for you guys, honors, and we will just be doing Q&A. So it might be a good idea to be prepared with some questions so we don't have to sit around and talk about sports and anything else for 10 minutes, okay? Cool. I will see you guys then. Stay out of trouble. Stay safe. Stay healthy.